3 minutes, we'll master the basics of working with square roots, simplifying, multiplying, rationalizing denominators, core identities, and a quick look at nested radicals. Let's go nice and chill, step by step, with zero mistakes. First, a tiny toolbox. 4 non-negative numbers, a and b. 1. Square root of a times square root of b equals square root of ab. 2. Square root of a plus square root of b is generally not equal to square root of a plus b. And 3. Square root of a squared equals the absolute value of a. We'll use these repeatedly. 1. Simplify by pulling out perfect squares. We look for factors like 4, 9, 16, or 25 inside the radical. Part A. Square root of 50 plus 2 times square root of 8 minus square root of 18. Factor each radicand as a perfect square times the rest. 50 is 25 times 2, 8 is 4 times 2, and 18 is 9 times 2. Then pull out the square roots. 5 root 2 plus 2 times 2 root 2 minus 3 root 2. Combine like terms to get 6 root 2. Part B. 3 root 45 minus root 20 plus 2 root 5. 45 is 9 times 5, and 20 is 4 times 5. So we get 3 times 3 root 5 minus 2 root 5 plus 2 root 5. The minus and plus 2 root 5 cancel. So the result is 9 root 5. 2. Multiply and combine. Part A. 2 root 3 times 3 root 12. Multiply numbers with numbers, roots with roots. 2 times 3 is 6. Root 3 times root 12 is root 36, which is 6. So the product is 36. Part B. Root 5 plus 2 root 2 times root 5 minus 2 root 2. This is a difference of squares. A plus b times a minus b equals a squared minus b squared. So we get 5 minus 2 root 2 squared, which is 4 times 2. That equals 5 minus 8, or negative 3. 3. Rationalize the denominator. We remove roots from the bottom by multiplying by a smart form of 1. Part A. 5 over root 3. Multiply top and bottom by root 3. We get 5 root 3 over 3. Part B. 2 root 2 plus 3 over root 2 minus 1. Use the conjugate root 2 plus 1. The denominator becomes 2 minus 1, which is 1. Now expand the numerator and collect like terms to get 7 plus 5 root 2. 4. True or false? Is square root of a plus square root of b equal to square root of a plus b? No. In general, that is false. For example, root 2 plus root 2 is 2 root 2, which is not equal to root 4 equals 2. But root a times root b equals root a b is true for a and b at least 0. 5. Nested roots. We try to write them as p plus q times a simpler root, then square and match coefficients. Part A. Square root of 6 plus 2 root 5. Assume it equals p plus q root 5 with p and q at least 0. Squaring gives p squared plus 5q squared plus 2pq root 5. Match terms. P squared plus 5q squared equals 6, and 2pq equals 2, so pq equals 1. That gives q equals 1 over p. Substitute to get p to the fourth minus 6p squared plus 5 equals 0. So p squared is 1 or 5, giving p equals 1, and q equals 1, or p equals root 5, and q equals 1 over root 5. Both give 1 plus root 5. Therefore, the expression equals 1 plus root 5. Part B. Similarly, square root of 3 plus 2 root 2 equals 1 plus root 2. Same method, quicker conclusion. Recap. To simplify roots, factor out perfect squares. To multiply, multiply coefficients and combine roots under one radical. To rationalize, multiply by a smart one, often a conjugate. Remember, root a plus root b does not equal root of a plus b, but root a times root b equals root ab for non-negative a and b. Nice work.